Let's look at port scanning. I've got a shortcut to the connection to my classroom. You might have to look for yours under your network connections. Enter my password. And I've been having trouble with that today. And if you have to re-enter your password here, don't bother putting anything in the domain. Okay, I'm in. Going to open up a remote desktop connection to my server. You'll have a different number here, some machine that I've assigned you to use. I always clean this up, the username, just down to the username that itself. Again, enter your password. Might take a few seconds for the connection to be established. It wants to know if I want to change my password, and I'm okay today. So we're going to do port scanning today, and I'm going to use SuperScan. I've got a shortcut on my desktop here. Network applications and network services running on a computer, they have to have a mechanism to know what traffic, what packets to respond to. And so they do this by monitoring the destination TCP or UDP port number in the packet. For example, if you have the domain name system running on a computer and a packet arrives addressed to that computer and the destination UDP port is 53, that tells the operating system in the TCP IP stack, and it basically tells it what to do with the packet, and that's pass it on up to the DNS service at the application layer to respond to that packet. So what we're going to do is we're going to basically ask a computer which of its TCP ports or UDP ports are listening, or actually have software that is monitoring for activity on those ports. And to do this, we're going to use SuperScan. So the last thing I did was a ping only, so I'm going to select one of these other radio buttons here, and let's do all ports from port 1 to, let's just go 200 here. You can do all 65,535. That will take a while. And I'm going to pick out a single machine here, and this is what was in here from before. If you recall here, we're on the 192.168.157 network. I'm going to probe or scan, do a port scan on just one machine, the 157.1 machine, just to show you how this works. So I'm going to click on Start here. So again, what we're doing here is we're scanning ports 1 through 200 on this particular computer, a single computer, to see how many ports are listening. And this is what SuperScan has determined here. It's found 4 open ports on this machine. By the way, this 157.1 machine is it's a computer with multiple network interface cards, and I've got it set up functioning as a router, and it's running Windows Server 2000. And it's been doing this for several years now, very happily. So SuperScan has discovered 4 open ports, and I'll show you in a moment how it has decided these are open and the other 196 ports are not open. And by open, I mean that there's some software, service, or application on this machine that's listening for traffic that's that's destined for these port numbers. So we've got 4 here. The 135, and this is TCP port 135 and 139, are associated with Windows networking. You can also tell from here that for some reason the web service has been installed on this computer, which was, if memory serves me well, it was a standard thing on Windows 2000 server. You got the web service whether you wanted it or not. If you hit the little plus sign here, you will find out that this is running server IIS, Microsoft IIS 5.0, and that does tell me that it's running Windows Server 2000, because IIS 5.0, the Internet Information Service 5.0, is the version that runs that came with Windows Server 2000. By the way, this is called a banner, and I'll show you about this in a few moments. But from an attacker standpoint, this has given, if I was an attacker, this has given me information, and I just told you what it was. I know 2 things now. This is in fact a Windows machine. It's also a Windows server, and it's Server 2000, and it also is running IIS version 5, and there may be something in here I can exploit. So I've learned a lot from my little scan here, because now I know that port 80 is open and listening, and what version of the web server software is actually running on it. Let me expand this. Port 25, TCP port 25, is the Simple Mail Transfer Protocol port, the port it typically runs on. And again, we're given the version number that's actually running on this machine. This is actually the computer's net BIOS name, MACC-207 router. It used to be located in room 207. So, from an attacker standpoint, I've learned quite a bit here by doing this port scan. So, let me show you what a port scan really looks like. Now that we've done one, I'm going to go over here and open Ethereal, which is packet sniffing or packet capturing software. There was a split with the names. There's also something that looks pretty much like this called Wireshark. You can use either one you want. There are other packet capturing software out there. I like this because it's free. So I'm going to go to Capture and Options. We've got to set a couple things up here. We have to pick the proper interface. Now, this machine has virtual machine software installed on it. So you get these VMware virtual adapters. You don't want that. I'm going to pick this Intel adapter here, and I can look up here at the IP address 192.168.157.251, and this tells me I've picked the right adapter. I'm going to click off the capture packets in promiscuous mode. That will give me too much traffic. I'm also going to take out this filter. You probably don't have a filter in yours right now. So I'm going to click on Start here, and this is going to start the capture. And there's going to be traffic here that I'm not interested in. But if I come back over here and click on Start again, I'm basically going to restart the scan. And when the scan is over, I'm going to stop my capture. Okay, so stop the capture. And I can minimize this. Now, once again, I've had students in the past get confused on this point. You don't have to run Ethereal to do a capture. As a matter of fact, most people that run scans, port scans, they don't run the packet capturing software, because that's kind of what the scanning software itself does. It looks at the traffic coming back and makes a judgment based on what it sees. I'm running Ethereal here, a packet capturing software, because I want you to see what the scanning tool is really doing. So you can scan without Ethereal. You can use Ethereal without scanning. They're two separate things. In this case, I'm using them together and I'm only using ethereal because I want you to see what the scanning tool is doing. So in ethereal, you're going to see a lot of traffic here. We could have filtered this out. What you're really seeing here is between 251 and 103. 103 is the IP number that's been assigned to my computer at home, my laptop. So what you see here from TCP port 3389 to 2109 and back, this is the remote desktop session that I'm actually using to run things on my server in my lab. So that's the remote desktop connection. Anything with 3389 and it's going to be a remote desktop. So let's scroll on down here a little bit and see till we see what where the actual scan happens. And this happens right here. First, we're going to get an ARP request from my server. It's addressed, it's a broadcast, so it's an ARP request, asking who has 157.1. 157.1 replies with its MAC address. So now my server has the MAC address needed to put into the destination MAC address field on the frame. So now I can send these packets. It follows this up with a ping request and a reply, and that determines for certain that the computer is up and running. Now here from 251 to 103, again that's the remote desktop traffic. This packet number 85 from 251 to .1, from a port on 251 to port 1 on the .1 machine, we have a send packet. Look what comes back from 157.1 port TCP1 on that machine. We get a reset acknowledge. That tells the scanner, in this case SuperScan 3, that there is no listening application on that port. So the reset acknowledgement coming back says, okay, there's nobody listening here. We get the same response on port 2. We get a reset ACK. Port 3, we get a reset ACK back. So there's nothing listening on ports 1, 2, or 3. Let's go on up here and find one that we know we have listening, something listening on. That's port 25. So here is my server sending a packet to the 157.1 machine, and it's sending it from, this is on the 251 machine, to SMTP. Now ethereal, you can turn this behavior off. Ethereal knows that port 25 is usually the simple mail transfer protocol, so it has substituted port the words SMTP here for port 25, and you can verify this down here. Notice right here, port 25 is the destination port number, and there it is in hex. So let's look at what happens here. Port 25, the scanner told us this is open. From coming back from the .1 machine to my server, from port 25, we get a send ACK packet. Now remember the three-way handshake that has to be established before TCP actually communicates. You do a send, and then a send ACK, and then finally an ACK. Well, here's the send. This is the send ACK back from the destination. Here's the final ACK from my computer. Now we've established a connection here. So if there is a service or an application listening on a port, you should get back from that computer a send ACK packet. Basically, It's the second part of setting up a connection. In this case, my computer, my server, sent back the final ACK packet, and then also did a request. Actually, got a reply from the server, and this is the actual packet here that contained the banner information I was showing you a while ago. See, here's all the information that came back from that the mail service running on that computer. So let's review. A port that's not listening will send back typically a reset acknowledgement. Reset and with an acknowledgement set. That tells the scanner nobody's listening on that port. A listening port will send back a send ACK packet that tells the scanner that there really is an application or a service listening on that port. Depending on the scanner and how you've got it set up, your scanner might send back the final ACK packet and trying to elicit the banner response. So in this case, we've discovered that port 25 is open. Also found out what version is running on that port, what software and what version. So we've got a lot of information here. If we scroll on down here, notice there's a lot of sends and then corresponding reset acknowledgement packets that indicate closed ports. If we go on down to port 80, that'll be pretty interesting, because remember, that's where the web server is listening. I passed, I think I did. And they're somewhat jumbled up here. Here you go. This is from my server to port 80. Notice here the destination port's 80. And again, Ethereal knows that the HTTP service is typically running on port 80, so it just substituted HTTP here. Send from my server to .1. Back from .1 I get a send ACK. My computer sends the final ACK. It also sends a head request, basically for a web page, well, basic information about the web server. Coming back from the web server, I get this information. If I expand this, this is where I'm told that it's Microsoft iOS version 5. So from an attacker's standpoint, now I have valuable information as to what's running on this computer. Now let's review. Open port, listening port, you get a send ACK packet back. Closed port, you get a reset acknowledgement packet back. You may be sitting there thinking, well, this is all well and good, but why do I care? Well, here's the deal. Any service or application that's running on a computer that's listening on the network, well, any software, whether it's listening or not, but it's just easier if it's listening on a network. Any software can have errors in its coding. We call these vulnerabilities. Once a vulnerability is discovered, it's possible to write exploit code that can take advantage of this vulnerability. And in a lot of cases, it's possible to exploit the vulnerability and actually gain control of the computer. So this is why an attacker is interested in this. It's a possible mechanism to gain control of a computer. And once they gain control, they can do any number of things they want to do. So this is why attackers do port scanning. They're looking for open ports, and if they can identify what's listening on these open ports, and they can find exploits for any vulnerabilities that might be in the software that's listening on on these open ports, they might possibly be able to exploit your machine and take it over. And then they can do whatever they want. So that's the connection. That's why attackers use port scanning. From your standpoint, you should port scan your own computers to determine whether you have applications running that you didn't realize. Like, for example, a few moments ago there, when I scanned the .1 machine, I was reminded that it's Windows Server 2000, and by default IIS version 5 is installed on that. Now really, I should go in there and disable that and uninstall that software, because I don't need it for that particular computer, and that's just another possible source of vulnerabilities that I have hanging out there. Now, I'm not terribly worried about this in this case because it's a machine on an internal network, and I do kind of let students scan it and find these things. But in a production network, I don't want to scan my computers and see what's listening and ask myself the question in every case, is it absolutely necessary that this be listening, or can I uninstall this application? Can I turn this port off? Or whatever. You want to minimize your potential sources of vulnerabilities. So that's why you should be interested in port scanning. And this is very important concepts to understand.